profiling. People in the audience have noted that they haven't had experience mostly with profiling before, so I'm going to show this from the start. What I've just done is loaded in a model that many of you will have seen before. This is his mule deer model that Cheryl here helped guide and shape. And here we see a large population of deer exhibiting movements over landscape. Worth their time, I would illustrate some of the complexities of this model by illustrating some of the factors related to their group behavior and their time-varying, seasonally varying state charts, etc. But there's a lot of mechanism in this model, and the model requires quite a bit of computational effort to run its more recent versions. This is an earlier version where the demands were less, but still, particularly as the population rises, it's a fairly demanding model.
Island.
Yes, there's the deer island. That's that is.
Everything is there.
Yeah, exactly. And you'll notice it's growing without bound now. The population, right? Oh gosh.
I've actually seen it do that before. That's cool.
Okay, it looks like somehow chronic wasting disease got introduced into that island. That's.
Killed them all.
Oh yeah, now
And I don't know if that's. Gosh.
Well, there's a little land bridge there.
Oh, there's, okay, yeah. Okay, so this model exhibits many virtues to recommend it, including texture. We're going to take a look at how you can profile this model, okay? So I'm going to call up this profiler here. It's Visual VM. It's a cross-platform profiling tool that is distributed now with Oracle's distribution of JDK, the Java Development Kit. You can also download it separately. This is an earlier version of it, as I recall. I think I have a rather more recent version. And when you call it up, you'll notice that it shows some information here that particularly for those of health science background will be reassured, refers to process IDs. And those indicate various processes to which you can attach. In other words, various running things. In this case, we're gonna start up this model, and we're gonna go back to our thing here, and you'll notice there's now a new one here. This PID 6844, right? What we're going to do is we're going to start the model running, and we're then going to request one of two things. We can ask it to sample the model and say, I'm going to sample sort of where it's spending its time, what sort of methods are causing it to occupy a lot of its time. Now, some of these are built in any logic. Many of them are built in any logic methods, but you notice this find nearest terrain, for example, is taking quite a lot of time just in its own code. So there's 389 milliseconds, or about 0.6% of the time thus far. We can also look at things like the memory, how much is allocated to different things. There's some big int array, which I suspect has to do with the terrain sizes, etc. But fundamentally, by looking here, we can get a sense as to, where is it spending time. This heading random, for example, is taking a fair bit of time as well. We can sort by this to get the largest ones. And again, find nearest terrain is increasing. Often you want to start this profiling after you've started the model and let it go through any burn-in period or initialization period, because there's often different processes in the initial period than there are later. and sometimes it will take a while for it to find it. In this case, we see quite a bit is associated with the presentation of the model. In other words, just keeping the model's visual appearance going. I think that a lot of that is the presentation $panel $d.run. I think a lot of that is associated with the sort of presentation layer stuff. But there's quite a lot in the so-called engine, which is probably dealing with things like state charts, etc. And that's actually taking the bulk of the time now. So this is one mode in which this runs. And Winchell can correct me here, but Winchell, the sampling distinction, as opposed to the profiling distinction, is one taking into account with sampling, you're just seeing in which method when you wake it up periodically, what method you're located, and profiling is what's you're taking into account the the fact that yourself and anything you call. Is that the distinction referred to here?
I thought, and
Yeah.
I understand, the sampling actually gives you the state of the program running at the time t at a moment.
Right, at the
While
moment t.
Profiling actually gives you a cumulative.
Oh, okay. So I stand corrected. So profiling is the cumulative one. I was saying both are cumulative. Profiling is cumulative. Sampling is just at that moment.
That's what I understand.
Or it must be for a short interval of time, because at a moment you're in a very particular place for a thread. So it's got to be for some short period of time. Yeah. Okay. So here what we're seeing is a cumulative component. And here you can see there's some stuff associated with the event queue handling. So there's a lot of events going on here. And there's a lot of calls to certain things. For example, this get presentation, that's also getting called a lot. A lot of these are actually built-in things, aren't there? Aren't they? In other words, a lot of these are not things very specific to your model at all. They're actually things provided in the AnyLogic framework. So, for example, that find terrain types is not well represented here. Instead, these are AnyLogic mechanisms, which may be called by those, which may be called by yours, but which are in the underlying AnyLogic system, right? So it's interesting that those predominate here, but we'd have to check very closely what this sampling distinction is. And in fact, we might want to look at the documentation. In fact, Winchell, could you look at that right now, just a little bit, just the definition of the sampling?
The sampling actually has a slightly different approach.
Okay.
The sampling also, the main purpose of that is actually dump all the stack in the object, and basically the main purpose of that is doing analysis of stack traces. So it's fast, but it's also only giving you the current status of the program runs. It doesn't count how many invocations of the method and how many.
Okay, but it is counting the self time, so it's counting how long it's spending on these.
Yeah, I mean, but that's the CPU, right? You're looking at the CPU, or you're looking at the sample? It's too far away.
This is sample.
Okay.
Yeah. So I think this is the amount of cumulative time that's spent. It's only rising monotonically.
Okay.
Rising is staying the same. So I think this is a cumulative measure. If we were to display this as a, and this is the final thing I'll do here, if we were to look at this as a parameter variation experiment, let's try. Hey, let's do it with the particle filter model. Now that would be interesting, eh? Would it not? Would. Okay, so let's take a look at with particles. Okay, so let's do it with a scale-free network. Here we go. And let's actually give it a larger particle size, right? Come on. There we are, dimensions, boom. Let's give it 999. Okay, now for this one, we're going to need to now go over this again. We're going to need to find the new one here. Got to be careful about that. So I believe it will be this one. Okay, so now let's start this up, and let's go sample this. Okay. Yeah, so there's quite a lot going on with manipulating the so-called hyperarrays. Those are for the subscripting, for example. Calling normal quite a lot, but it's not too heavy. Oh, okay, the Poisson here, assign context per week, so that perturbation, sample particle by weight is taking a fair bit of time. But you'll notice it's overwhelmingly up in this this stuff associated with the presentation. I mean, there's a lot of presentation stuff there. Now the question is, could I actually have it do a parameter variation experiment here? Let me just wing this. I'm going to do an experiment. This is. I already have it. Okay, look at that. Okay, watch this, folks. This is a parameter variation experiment. Okay, so we're going to go here. Oops, Visual VM. Okay, so here we go. Boom. Okay, you folks ready? Okay, let's start it up. Boom. Okay, and then we're going to sample. Let's see what's taking time here. Okay, press the CPU to sample from the central processor. Okay, now a lot of the presentation stuff has been greatly reduced. Still this C thing, but you'll notice more and more it's dominated much more so by these other components. There is still a bit of presentation stuff, but that's probably dependent on sort of how frequently I tell it to refresh this surface. But this get positive, the sort of indexing by particle within the subscripting, that's dominating more. There's normal and Poisson assigning to this. These are all assigning taking quite a bit of time. So anyway, this is it's just showing profiling associated with models, so you can figure out what's taking the most time. If there's certain bottlenecks. In Winchell, recently you did profiling for the CWD model, I think, right? And that's something Cheryl might want to know about. What did you find? Where was it spending its time?
Well, the way that the deer is trying to choose the next location very on.
And what fraction of its time was it spending there?
It's the function which will determine the next location the deer will be moving.
Right.
Move next stack.
Right. But what fraction of the time was it spending there?
You mean how much?
How much time?
Roughly 69%.
69% of its time in this one function. So that would be a bottleneck that we can address. And really that's the sort of insight you can get from this sort of profiling. Where are the bottlenecks, which allows us to proceed to trying to address them. Yeah. Okay, so that's all for today, and thanks very much. We'll reconvene 9 o'clock tomorrow morning for another round of presentations. Okay? Okay, thanks.
We have a seminar in the morning.
Yes.
Yeah. Computer science seminar.
What you're going to say is about time you take, Chad.
Oh.
Oh, good shit.